Hello, I want to show you exactly what we're going to build today. We're asking what are people saying about AI and also machine learning in London, UK with the radius of 100 kilometers. So here we can see the result. People in London, UK saying about generative AI and also according to different users. So here we can see the exact usernames. It's pulling insight from the entire graph structure that we built. And that's the power of the GraphRAG system we're going to implement right now. So this is the notebook we are using today. And you can find this one on our GitHub repository. And then you can just open it in Colab. And in our previous tutorial, we use this Python notebook to generate some dummy tweets and also store that into a Neo4j free instance. So that is the structure of our network. So a user can send out tweets. The tweets can be located at different places and also tagged with different hashtags. So that's the data that we already have. If you don't have such data, or if you want to create new tweets, you can just try our previous Python code. What exactly is a GraphRAG? So traditional RAG system just retrieve the different embeddings separately. And with a GraphRAG, every dots are connected. So we're going to build an embeddings based on the tweet text, and then we are going to follow those informations to enrich those contexts. Finally, we're going to pass those enriched contexts to large language models so that they can provide us the grounded answers. So our first step is to install those Python library. We need to install the Neo4j Python library, which can speak with our Neo4j instance. We also need to use Gemini, so that can use as our large language model to generate embeddings and also generate the answers. Next, we're going to connect to our Neo4j and also Gemini API. So we already have this instance that is running and also that has the tweet data. You need to provide those API keys for your Neo4j instance. So you need to have your password and also URI. So if you follow our previous tutorials, you know how to get that. We also need to use a Gemini API key. Let's first create a new API key, and we're going to call it Gemini API key. And then you just go to your Google AI Studio. Right now, I just try to create an free API key. So we start with a project, RAG, project, graph, RAG, free API key. All right, so now we have this API key, and I'm going to copy this API key. And you can see we are now using this free tier. And of course, you should never share your API key with other people. And now go back to our Colab. I'm going to paste that API key. I also will give access to this notebook. And if you don't want to use the secrets, or if you are running this notebook on VS Code or other Python editors, so you can store your API key into your Google Drive and store everything into this .env files. Now we're going to test. So here, let's try to import those API keys. So this piece of code will first try to use the Colab secrets. Next, we're going to verify the graph data. So now you can see here, we have a summary of our data. Now we're going to generate the embeddings. So embeddings are the multi-dimensional numbers of vectors. For the text that have the similar semantic meanings, they will be close to each other in this multi-dimensional space. So we are going to pass each single tweet to our Gemini embedding model. So here we're going to using the embedding 001. And also we're going to add one embedding field into our tweet data. And you can see for this embedding, the dimension is more than 3000. So let's define the function. So this code will generate embeddings. So it will search embedding first. If you have embeddings, then they will skip generating embeddings to save your API. If you don't have embeddings, like right now, I don't have any embeddings, and I will generate embedding for those 100 tweets. So let's run it. All right, so now you can see I'm generating those embeddings, and it's pretty fast. So let's look at the embeddings in our Neo4j database. So here, let's go to query, and let's go find our tweet. And let's just check one tweet. So double click. And now you can see those are the embeddings. So the tweets that have similar semantic meanings will be close to each other. Let's also check the usage. So if I go to the usage, here you can see for the embedding models, we reach the limitation. Once we have embeddings, and if you ask the database to find out the similar text, we need an index. So we're going to Neo4j ANN search index, that is a nearest neighbor search index. All right, so here you can see we just defined that index. So index is now working. And now we can ask question, for example, what are people saying about graph database? We first generate an embedding of this single question, and then we use this index to find out the top 5 tweets that has a similar contents. Here we can see that those are the top 5 tweets, and we can see the scores pretty high. Okay, next, that's the power of this GraphRAG. Send out query, for example, what people talking about in New York. We find out the tweets, and then based on these tweets, we're going to also retain the user information, the place information, and the hashtag information. And we can expand further. So if you like, you can expand further to just, find out more tweets, more users, or more place informations. So that will enrich your context. You can see we're going to get author based on the retained tweets. We'll get information and also hashtags based on retained tweets. So let's define this GraphRAG search function. And now we can try some examples. So for example, what are people saying about graph database? You can see here, we have those information that have been retained. We can see it's the same tweet text, but here we can see they belong to different users or different locations or different hashtags. Okay, so that can provide enriched context based on the graph search. Okay, so now in step 7, we can build this 4-rack pipeline with Gemini. So the difference between 7 and 6 is that in step 6, we just retain all the retrieved information and also their users, places, hashtag, etc. So in step 7, we're going to pass those information to a large language model and let large language model to generate answers. So here we're going to compare 2 approaches. The first is called RAG answer, which means that we're going to pass the vector search results only to the large language model. In this case, it is Gemini, and also let Gemini return the result to the user. And the second approach is called GraphRAG research. So the GraphRAG research will return the result from this GraphRAG search. So it includes the tweet text and also the related user information, place information, and hashtags. We pass all the information to Gemini, and Gemini will generate the answer based on this enriched context. I'm going to test one question only. So I'm going to test this question. So which cities generate the most discussion about AI and also cloud computing? So let's pass that one to Gemini. All right, so let's look at the result. So if you're using a traditional RAG, so the vector search only, we can see it does not give you any information because it does not have the specific cities in those tweet text. However, if we look at the vector plus graph search, we can see we have this answer because when we pass the result of the tweets, we also pass their location information and also user information. So we can see that answer is that UK generate most discussion about AI and cloud computing with 3 tweets from this user, and also Japan, 1 tweet and from this user. Okay, so now you can see the power of the GraphRAG. So if you want to do an interactive query, and you can see here we can ask what topics are trending in San Francisco. And you can see that here we are still using the GraphRAG. So you can see cloud computing from 1 tweet by this user. The tweet is located in San Francisco, and also the content of the tweet is like this, and also included 1 hashtag. We can also train the large language models to write the Cypher queries for us. So the idea is that, so sometimes when the user asks an analytical question, how many tweets per city? And if you use large language models, so they may not give the answer directly, we can let large language model to generate Cypher queries. The approach is here. So we pass questions to the large language model, and also the large language model will, based on this question, to generate the Cypher query, and also ask the database to run that query. And database will return the results back to the large language models, and large language model will return the result to the users. Okay, so let's try this example. You are an expert in Cypher queries, and when you give answer, and you can generate Cypher queries. So here we also mentioned what is the graph structure in our database. And also we say you only return a raw Cypher query. So let the large language model generate the query. And then we're going to pass that query to generate the result. And finally, we will let the large language model to summarize the returned result. Okay, so that is ready. So let's try it. So here we're going to ask two questions. One is that which user has the most followers? And also second one is how many tweets are posted from each city. So let's try those questions. So you can see for the first one, so that you generate Cypher query based on this question. And here you can see that based on the results, large language model gave us answer that the user with the most follower is this one. And also we have a summary of this person's tweets. And our next question is that how many tweets were posted from each city. You can see this is generated the Cypher query. And also here are the results that's generated by AI. We have 23 tweets from Tokyo, 23 from San Francisco. Or can also do the spatial queries. So for example, we can find out the tweets that close to a specific point. And once we find out those tweets, and then we can do a lot of other research. Let's try to implement this geospatial query. Here we're going to provide the city name, radius, and also the number of limited results returned. So first, we want to find out the number of tweets in San Francisco with a radius of 50 kilometers. So you can see those are the tweets that within this radius. We can also compute the inter-city distance. So that's also available in Neo4j. Here we can see the distance between different locations in our database, London to Paris, New York to San Francisco. All right, so now we reach to our final step. That is this Geo-Augmented GraphRAG. Okay, so it has 4 different functions. So it has a geo-filter that finds out tweets within the radius of city. It can do a vector search. So among those geo-filtered tweets, we can find out similar ones. And then we're going to do the graph retrieval. So we're going to find out the related users, hashtags, and also relevant content so that we can enrich our information. And finally, we're going to pass everything to large language models to generate our final answer. So here we're going to demonstrate those 2 questions. So the first one is asking what are people saying about AI and machine learning. So we are limited to tweets in UK and also do a semantic search and also do the GraphRAG retrieval. Our second question is that what do people thinking about cloud computing and serverless? And we will filter tweets in this city first, and then we find out the relevant tweets that are talking about the same topic, and also retrieve the user information, etc., and also generate the final answer. So let's try the first one. Okay, so you can see here are the results. So people are discussing several aspects of AI and also machine learning from London, UK. So large language models, transformer models, and also generative AI. They also mentioned the user informations. So second one, you can see that regarding the serverless architectures, user generally have the positive views, and also, however, there's concerns about cloud computing cost. Okay, so that's very nice. And when you're done, you can just simply close your connection to your Neo4j instance. And you can see that we just almost reached the limitations because we just embedded 100 tweets. And also for the Gemini 2.5 Flash, so we asked several questions and also we almost reached our limitations. But you can see that so the free API is working, so you don't need to use a paid API. So that's good news. All right, so we built a complete GraphRAG pipeline from the social media knowledge graph. So if you don't have the data, you can check our previous tutorials and to set up your Neo4j instance. And today we just use a free API to create those embeddings. And also we implemented the GraphRAG and also implemented a Geo-Augmented GraphRAG. So as always, the full source code is on GitHub. So please give it a try with your own search terms.